So good evening once again. Now we will see a short video of the JK Latch. Let me start sharing my screen. Hope you're all able to see my screen. So now it's JK Latch. So here in the JK Latch again, this is a latch where you have two inputs. One of the input is J and the other one is K. Usually JK latch will be constructed over a SR latch because SR latch is most widely used latches. We here in this case we have taken the example of SR using a NOR based latch. So make a SR using a NOR based latch. Okay. Above that, construct a JK latch using an AND gate. Fine. So this is the first one. Make the circuit diagram. Again, we need the AND truth table and SR using NOR truth table. So here I'm going with SR using a NOR based truth table. Okay, so here in this SR using NOR based truth table, we have already found how we have got in the SR latch topic. The same truth table, we are just making it here for our reference. So in case one, let us take, two input combinations. So it is 0, 0, 0, 1, 1, 0, 1, 1. That will be the all the four cases, right? So let's go one by one. Case one is J and K are assuming to be 0. So what will be the output? Is it possible to find if one of the input combination is 0? Yes, definitely. An AND gate will give us output high only when both the inputs are high. 1 and 1 only, an AND gate truth table, you will get an output. Okay. For all other combinations, if at least one of the input combination is 0, the output is definitely going to be 0. So now let's start. Both the cases, J and K, both are 0, 0. One input, you just know one of the input. Here in this particular gate, K is 0. Here in this particular gate, J is 0. Irrespective of what was our other input, you'll be able to land because it's an AND gate. Definitely the output is going to be 0 and 0 in both the cases. So now this part is a SR latch. So now SR has got the inputs as 0, 0. So what will be the output in an SR 0, 0? No change, because in SR for a 0, 0 input, what we have found in the SR latch, it is going to be 0. So here also it is a no change. So if we are assuming the previous output as 0, you will get 0. If you are assuming the previous output Q as 1, we will get 1. So now let's go to the second condition, 0, 1 combination. So here J will be given 0 and K will be given 1. Okay. So now, is it possible to find the output of this and this gate? Only this gate will be able to find, because one of the combination is 0. Whatever may be the combination of the other input, let it be 0 or let it be 1, definitely this will be 0. But here we can't go by it, because if this particular input is 1, we will get an output like 1. So R will become 1. Otherwise, if this is going to be 0, you will get an output 0. So R will become 0. If R is 1, your output will be reset. If R is 0, your output will be set. So we can't go by it. So what are we going to do? We are assuming the previous state as 0 and we are trying to find. Okay. We will assume both. We will assume, whenever we are assuming, we will assume both the possible state, all the possible states. There are only two possible states, set and reset. So let us go by it. So we are assuming the previous state as reset first, and we are going to find what will be the output. Okay. So this 0 in Q, what you got, this output Q is just traveling through the feedback. Okay. This output Q, what we have assumed, is traveling here, and we get here in the first AND gate, here we have got 0. Okay. And if this Q is going to be 0, Q dash will be obviously 1. So this 1 will be given as a feedback loop to the second AND gate. So now we got both the inputs, 0, 1, 0, 1. So now let's easy for us to find the output. So in this case, we are getting 0 and 0. What was our output? This 1 will traverse here. Okay. And this 0 will traverse here, and we are getting the output as 0. What does 0 means? It is means a reset condition. So now let's check whether even when you assume Q to be 1, will we get a reset condition? Reset means Q will be 0. Let's check that. So again, we are assuming J to be 0 and K to be 1. And previous state, we are assuming only one gate we'll be able to know. This gate we will not know. So we are assuming previous state as set. So this one, if Q is 1, Q dash will obviously be 0. So this one will travel here and this 0 will travel to the other input of this gate. So now we got the output 1, 1. What's the output? 1, 0 and 0. What's the output of this AND gate? 0. So now R is equal to 1 and yes, this is your yes and this is your R. Okay. So R is equal to 1 and S is equal to 0. What was our output? 0. Because in SR, when R is 1 and S is equal to 0, the output should be reset. So in both these conditions, we have got Q to be 0. So what are we concluding? When J is equal to 0 and K is equal to 1, it behaves as a reset state. Now let's take the third state. Third state is J is equal to 1 and K is equal to 0. So in this case, we are going to test it. Again, here also, it is not possible for us to find the output of this particular gate. So what we will do, we will assume the previous state as set and reset. So now let us first assume the previous state as reset. Q is equal to 0. So obviously Q dash should be the inverse of it. Q dash will be 1. So this 0 goes through the loop and the second input of the AND gate is 0 here. And Q dash output 1 travels through the feedback and the second input of this gate will be 1 here. So we'll be able to find the output 0, 0. Your output was 0 here and 1, 1. Your output will be 1 here. So S is 1 and R is 0. So how do you get your output? This truth table. Refer the SR NOT based truth table. S is 1 and R is 0. You'll get the output set. So this Q will become 1. Is it all fine? Now let's check whether the previous state, if we assume Q to be 1, okay, how do we get the same set? So now we are again taking J is equal to 1 and K is equal to 0 and we are assuming the previous state to be 1, okay, that is set. So this one is traversing here to the first AND gate and here it will be 0, right? So this 0 Q dash will be 0. So this 0 will traverse here. So what will be the output? Both will be 0. Okay. So in this case, when you have 0 here as the input, okay, what will you get? The output is 1. Okay. So it's a set state. The last condition, we are checking J and K to be 1, 1. So both J and K are 1, 1. So here in this particular case, when J and K both are 1, it is definitely not possible to find the output of even 1. So we will go by the same way. We will assume the previous state as 0 and Q is equal to 0. Q dash will be 1. So this Q1 will traverse here and Q0 will traverse here through the feedback. So what will be our output here? 0, 1. So R is equal to 0. Okay. And S is equal to 1. R is equal to 0 and S is equal to 1. What will be our output? Set. So it should be 1 here. Okay. But previously we assumed it to be 0. Now we are getting 1. So now let's check the other way around. Again, J and K are 1, 1. Okay, the previous state we are going to assume it as 1. So this 1 will traverse here. This Q dash will become 0. And this 0 will traverse here. So what is the output here? This will be 1 and this will be 0. So now R is equal to 1 and S is equal to 0. So R is equal to 1 and S is equal to 0. So what will be your output? Reset according to the truth table. So here reset means Q should be 0. So how did we get? It has toggled. If the previous state was 0, we are getting the output as 1. If the previous state is 1, we are getting the output as 0. So toggling is happening. JK flip flop behaves just like a T flip flop, toggle flip flop, when both the inputs are given 1. So we have now found the truth table for a SJK latch. 1 1 it is toggled, 1 0 set condition, 0 1 reset condition, 0 0 no change. Okay, with this I stop.